Here we go, video number 3, finishing up vertex form transformations. Okay, so for example 2, first we want to graph our parent function. So I graphed the parent function down here for you. Now we need to identify whether it's positive or negative. So we have our A, and we can see that A is positive. So we know our parabola is going to stay facing up. We are going to leave it that way. Now we know h equals 2, and we know that k equals 1. So positive 2 is telling us to move to the right 2, and positive 1 is telling us to move up 1. So I'm just going to grab my parent function from over here, or my new function, my transformation. I'm going to drag it over here, and we'll start at the parent function. And we know we're going to the right 1, 2, and we are also going up 1. So there is your new function. We went to the right 2, and we went up 1. So you can see it now in relation to the parent function. Okay, let's look at example B. We have A is negative 1, so we know we have to flip our parabola. H is 3, so we know we're going right, and K is negative 2, so we know we're going down. Okay, so I am going to grab my new function, and now it's negative, because A is negative 1. So I'm going to drag that over here. And it's just going to sit right here for now. Then I know I'm moving to the right 1, 2, 3, and I'm also moving down 1, 2. So there we go. That would be your new parabola. Now for the last one, I want you to try this one on your own. Pause the video and come back when you're ready. Are you ready? Here is this parabola in vertex form. You can see the relationship it has between its parent function. Negative A told us to flip the parabola upside down, and then we had to go to the left 2 and up 4. So there you have all 3 transformation examples. Now we have scrolled down, and let's just review what we have learned. First, some vocabulary to go over. Vertex. The maximum or minimum of a parabola. It's the highest or lowest point of the parabola. The axis of symmetry is the x-coordinate of the vertex. It's the vertical line that makes the parabola symmetrical. Okay, for A, let's find the vertex. The vertex is HK. So the vertex is 1, 2. So we're going to plot the vertex. 1, 2. Right. The axis of symmetry is going to be x equals 1. So this is our vertex, and our axis of symmetry is going to be right there. Now, we have to plot some more points. So you can either plug in 0 for x and find a y-intercept and then find one other point. You can use a table of values, or you can use the parent function. We know based on the rules for graphing a transformation in vertex form, that we need to go to the right 1 and up 2. If you look, based on the parent function vertex, we went to the right 1 and up 2. So that means all the other points are going to the right 1 and up 2. To the right 1, up 2. To the right 1, up 2. One up 2. Now we just make them symmetrical. And there you go. You just graphed a parabola in vertex form. Now we want to identify if it's a minimum or a maximum. This parabola is a minimum. We also want to identify the domain and the range. Okay, we need to identify the domain and the range of this quadratic function. The domain of the function is all of the values of x. And if you look at your parabola, it opens up, but it's not going vertically. It's not going straight up and down. It's kind of going out forever and ever. I should not have done those as dotted lines. Now I'm going to have to hit back a billion times. So it's going out forever and ever. So it's going to the left and to the right forever. So your domain is always going to be all real numbers, because it's always going to be going out to the left and the right, covering all real numbers forever and ever. So domain x equals all real numbers. Because you know, when we graph these functions, they don't stop. They go on forever and ever. We just can't graph them forever and ever. Now, the range, which is your y, range has a starting point. So the range for a positive function is going to start at your smallest y value. So our smallest y value here is 2. Y equals 2. So since the parabola is opening up, it's going to go on and on forever and ever up, starting at 2. So the range is going to be, y is greater than or equal to 2. So let's move on to B. The vertex for example B is 2, -3. So our vertex is over here. 1, 2, 1, 2, 3. 2, -3. So based on our parent function, where did we go from the origin? We went to the right 2, and we went down 3. To the right 2, down 3. So that's where our points are going to follow. We're going to the right 2 and down 3. You could also use a table of values for this. Since we kind of ran out of room, I'm just going to leave it there at 3 points. And I'm going to draw our little parabola here. Baby parabola. It still continues on and on forever. So the axis of symmetry is x equals 2, because the x value of the vertex is 2. That's our axis of symmetry right here. This is a max because the vertex is on the top. The parabola is opening down, so the vertex is the highest point, so it's a maximum. the domain is x equals all real numbers, because even though it's facing down, it's still going to the left and the right forever and ever. Your x, your domain, is the horizontal axis, so it's covering all values on the horizontal axis, all of them. So x is all real numbers. The range always starts at k, and k is -3. That is your, right now, your largest y value. It's your greatest y value. And because the parabola is opening down, it's going to be all of the points less than y equals, or it's going to be less than -3. So when the parabola is opening down, your range is less than or equal to whatever the value of k is, in this case, -3. So your range is y is less than or equal to -. Part C, I would like you to pause the video and try to complete this example on your own, and then when you're finished, come back and check. And here we go. Your vertex is -1, 1. The axis of symmetry is x equals -1. This graph would be a maximum. The domain is all real numbers, and the range is everything less than or equal to 1. Okay. Now the last thing we are going to do is write the equation of the parabola from the vertex and one point. The first thing we are going to do is plug in the vertex and an unknown point into vertex form. So we have our vertex form. Our unknown point has a y value of -1. We are going to be solving for a. Our unknown point has an x value. The point isn't unknown. I don't know why I said that. The point has an x value of -2 minus the x value of the vertex, which is 1, plus -4, which is k. So I am just going to rewrite this and simplify a little bit. -1 equals a times -3 squared minus 4. Now we can start solving. We are solving for a. So -1 equals, I'm going to even reverse this, 9a minus 4 at 4. 3 equals 9a, divide by 9, divide by 9, 1/3 equals a. So now we can rewrite this in vertex form. Y equals 1/3 times x minus 1 squared minus 4. And that would be our function in vertex form. Now let's look at B. So we are given the vertex, but we are also given the y-intercept. But you know the y-intercept is the value that we can find when x equals 0. So this coordinate is actually 0, -1. So don't fret, there is an x and a y value. Now we are going to go and plug in our values. So the y-intercept is -1. We are going to be solving for a times the x value of 0 minus -2, whole thing squared, plus 3. -1 equals a times 2 squared plus 3. -1 equals 4a plus 3. subtract 3, negative 4,